Hello everyone, this is Dr. C. Selvakumar, Professor and Head of the Department of Physics. In this video lecture, we are going to see about the piezoelectric crystal method for the production of ultrasonic waves, which is in the course Properties of Matter and Sound. In this video, we are going to see about the concept of piezoelectricity, the examples of piezoelectric crystals, the piezoelectric crystals cut for the generation of ultrasonic waves, construction of piezoelectric oscillator, the working of piezoelectric oscillator, merits and demerits of piezoelectric method. The concept of piezoelectric method. Before that, let us see about the sound. Sound in general has two categories. One is classified as the audible sound. The frequency of the audible sound is from 20 Hz to 20,000 Hz. The next category is the inaudible sound. In inaudible sound, there are two categories in the inaudible sound. One is having the frequency less than 20 Hz, and the other one in the inaudible sound is greater than 20,000 Hz. The sound waves having the frequency less than 20 Hz, it's called the infrasonic wave, and the sound wave which is greater than the 20,000 Hz, they are called as the ultrasonic wave. Both the infrasonic wave and the ultrasonic wave, they are not audible. Now our aim is to see how to produce the ultrasonic waves. In general, the ultrasonic waves are produced by means of three methods. One is the magnetosuction method, next one is the piezoelectric method, third one is the Galton vessel method. Out of these three methods, let us see about the production of ultrasonic waves by piezoelectric method. In piezoelectric method, the material used for the production of ultrasonic waves is the crystal. There are so many types of the crystal. In this figure, the slide, we could see a crystal which is mentioned as the quartz. In a quartz crystal, whenever a quartz crystal is subjected to mechanical pressure or squeezing or twisting, the crystal will generate the electric charges. This phenomenon is called as piezoelectricity. Therefore, in piezoelectricity, the crystal is taken, and in a crystal, when one pair of opposite faces of the crystal is subjected to a mechanical pressure, the other pair of opposite faces of the crystal will generate the electric charges. When the direction of the mechanical pressure is reversed, the charges generated also will changes. Instead of the electric charges, instead of the mechanical pressure, when the electric charges is fed to the crystal will change its dimension. When the polarity of the electric charges is reversed, the direction of the change in the dimension of the crystal also changes. Instead of a DC electric field, when an AC electric field is applied to the crystal, the dimension of the crystal during one half of the cycle may increase, and during the other half of the cycle may decrease. When the AC electric field is applied continuously, the change in the dimension of the crystal also will take place continuously. So this is the concept of inverse piezoelectric effect, The inverse piezoelectric effect is used for the production of ultrasonic waves. Piezoelectric crystals. There are many crystals that will exhibit the phenomenon of piezoelectricity. For example, some of the crystals which exhibit the piezoelectricity are quartz, rochelle salt, topaz, tourmaline, langasite, and lead titanate. Quartz is nothing but a silicon dioxide, a most abundant material at the Earth's surface. Rochelle salt, it is nothing but potassium, sodium, tartarate, tetrahydrate. Topaz is a silicate of aluminum and fluorine. Tourmaline, a crystalline boron silicate mineral. Langasite refers to lanthanum, gallium, and silicate. The last one is lead titanate. X-cut crystal and Y-cut crystals. Normally, the crystals are hexagonal in shape with the two pyramids at the opposite faces. In the figure A, we could see the line joining the opposite corners of the hexagon. It is called the z-axis. The z-axis is always called as the optic axis. In figure B, you could see the line joining the opposite corners of the hexagon. The line joining the opposite corners of the hexagon, it is called as the x-axis. When a crystal is cut perpendicular to x-axis, it is called the x-cut crystal. The X-cut crystal will generate longitudinal ultrasonic waves. In figure C, the Y-cut crystal, we could see that the line joining the opposite faces of the hexagon, the line joining the opposite faces of the hexagon is the y-axis. When a crystal is cut perpendicular to y-axis, it is called the Y-cut crystal. The Y-cut crystal will generate transverse ultrasonic waves. Now we shall see the construction of the piezoelectric oscillator. The principle used in the construction of the piezoelectric oscillator is the inverse piezoelectric method. In this circuit, the coil L1, L2 and L3, they are coupled by means of the transformer action. The variable capacitor C1 is connected parallel to the inductor coil. One end of the variable capacitor is connected to the base of NPN transistor, and the other end of the variable capacitor C1 is connected to the emitter of the NPN transistor. One end of the inductor L2 is connected to the collector of the NPN transistor, and the other end of the inductor coil is connected to the positive terminal of the battery and the emitter of the transistor. Working of the piezoelectric oscillator. When the battery is switched on, the tank circuit is set into oscillation or the vibration. An EMF is generated in the tank circuit. The frequency of oscillation of the tank circuit is determined by the equation F is equal to 1 by 2 pi into root of L1 C1, where L1 is the inductance of the coil, C1 is the capacitance of the capacitor. The inductance, the EMF generated in the inductor L2 is fed to the transistor, and the input given to the transistor is amplified and fed to the collector capacitor. The EMF fed to the capacitor is inducted in the coil L3 by means of the transformer action. The EMF generated in the transformer L3 is fed to the piezoelectric crystal by means of the plates L1 and that is A and B. When the EMF, alternating EMF is fed to the crystal will oscillate. The crystal will oscillate with the maximum frequency when the frequency of the tank circuit is equal to the natural frequency of the crystal. When the piezoelectric crystal is placed along its thickness in between the plates, then the frequency is determined by the equation 1 by 2t into root of y by rho, where y is the Young's modulus, rho is the density, and t is the thickness of the crystal. When the crystal is placed along its length in between the plates, then the frequency is 1 by 2L into root of y by rho, where L is the length of the crystal. By this way, we can generate the ultrasonic waves in the piezoelectric method. This is a prominent method for the production of ultrasonic waves. Merits and demerits of piezoelectric method in the generation of ultrasonic waves. The frequency generated in this method is maximum and is greater than 500 megahertz, and the output is stable, the frequency is constant. This method is not affected by temperature or humidity, and it's the most efficient method among the three methods and more efficient than magnetostriction method. In the demerits, since the crystals are used in the production of ultrasonic waves, the crystals are costly. And before using the crystal in the circuit, we have to cut and shape the crystal in an appropriate manner. The cutting and shaping the crystal is a tedious task, it is a difficult one. These are the demerits of the piezoelectric method. Therefore, in this video lecture, we have learned about the concept and the usefulness of the piezoelectric method in the generation of the ultrasonic waves, and how to construct and what is the working principle of the piezoelectric oscillator. We have also seen about the merits and demerits of the piezoelectric method. Hope you could understand about the piezoelectric method in the production of ultrasonic waves. Thank you.